Anyone?
Yes, sir.
What about B section? Okay. Okay. Today experiment is analysis of fiber optic digital link with eye diagram. Here we are going to measure signal degradation, jitter, and by using histogram feature available in OptiSystem software. Okay, here, what is some small introduction about signal degradation jitter? Here, jitter is defined as the short-term variations of digital signals significant instance from their ideal position in time. In this experiment, we require the electrical signals and the clock signals from the PRBS in order to estimate the signal bitrate. Here then parameter sweeps are used to generate multiple eye diagrams for different values of jitter, amplitude, and frequency. Okay, what are the blocks or components you need to design the signal degradation from jitter? Okay, here normally yes, PRBS generator and plug NRZ pulse generator. Here one fork, there is a one splitter, one low pass Bessel filter, and one electric jitter block. Okay, here just you get the find the component. Just you type electrical jitter. This block is available here. One input from filter, another input from PRBS sequence generator. Then finally the BAR analyzer. You connect the BR analyzer and oscilloscope viewer to measure the signal degradation jitter. Okay, then what is histograms? Here, by using this eye diagram, you can find out the um, amplitude data of eye diagrams, offering important, that is a histogram are used to statistically analyze time and amplitude data of eye diagrams, offering important computational information when observing impairments in high speed digital signals. Here this is called the thin histogram tracing point. This is where we open complete eye view. In the these are zeros and ones are randomly uh, flowing here, so that in this manner you can calculate by using this rising and falling edge. Here in this manner jitter from eye diagram is taken here in this place. This diagram, um, rising edge and falling edge, based on that to calculate this jitter. Okay, then how to find the total jitter from the eye diagram? Okay, this diagram giving clear understanding. The jitter measurement are made with usual histogram gathered data as shown at the eye crossing point. This is for eye crossing point. Two thin histograms. This is the first one is the left crossing point, and this is the right crossing point. Okay, here to compute jitter, the time variances of the rising and falling edges of an eye diagram at crossing point are captured, showing here. This is your high weight. Based on that, this you calculate high weight. Here, the time histogram shown here. Eye pattern is analyzed to determine the amount of jitter. Okay, this figure shows eye width is the time measurement between horizontal histogram data slices taken at the inner 3s point, 3 sigma points here. Okay, by using this eye diagram analyzer, this figure shows total jitter of an eye diagram measured at eye cross point. This one, these are eye cross point, is horizontal point, as the difference between the time values of mark A and mark B. For that, by using scope, you need to mark this location A and B. The jitter is composed of two basic type. First one is random and second one is deterministic. First on that, these different information windows, by using the markers, you can just click left button and drag to zoom region, and also you press the control key and left mouse button to zoom out here. Here in this information window, it shows the markers value A and B value. Also, it gives the difference between A and B value. This is where a jitter calculation. Okay, here the A minus B, the difference between these 2 points, it shows the jitter value, this value. Okay. Okay, then by using eye diagram analyzer, the another thing to measure the using histograms, how to measure the jitter. Here also, this is your histogram V. In OptiSystem, we can use the eye diagram analyzer histogram feature to generate a histogram that shows a deterministic and the random components of the jitter. Is shown in this figure. This one, amplitude versus time. This here also. Click the left mouse button to place the marker here. Here to here, you are getting the histogram value. Here, this manner you have to measure the jitter. Okay, these are 11th experiment. The next experiment is design of basic optical communication system using OptiSystem. Previously, in the place of transmitter, we are using PRBS generator, NR pulse generator, and one more MZ modulator. Okay, within the by using this block, we can able to design one complete transmitter. It is transmitter is available in our OptiSystem software. Okay, then this part is transmitter. Here itself, you know very well how to vary the frequency, how to vary the power, how to vary the bit rate, and how to give the modulation type. Just to double click on that, you have to set the frequency, power, bit rate, and modulation type with your um, appropriate values. Okay, then this is your channel. Drag and drop optical attenuator. Here, no need to put attenuation because for basic analysis purpose, so that we can't give the attenuation value. Then optical receiver. Okay, here itself, some separate block is available. Optical, just you type in search components block, just you give the optical receiver. Yeah. Here you give the cutoff frequency as a default value. The default value is 0.575 into bit rate in terms of bits. Just you connect a bit error rate analyzer. Just you observe the diagram. These are layout shows basic fiber optic communication system design. So what is the difference between previous one? Means these are only within the single block we can able to construct or design any type of optical transmitter or receiver. Okay, finally, you just observe the by using the BR analyzer, observe Q factor, minimum BR value, threshold, height, and BR pattern along with the eye diagram. These are output simulation. It's a two simple simulation, two simple experiments are there. Just you go through. Later, I will share the OSD file also. Okay, now let us move with the simulation. Okay, this is your the first 11th experiment. So this is your PRBS generator. I leave the default values. Okay, here no values I have given here. I will give the what is the default value of PRBS sequence generator given. Okay, there this is what NR is set, pulse generator, and low pass special filter, and this is your electrical jitter. If say it's component, just you type the word jitter. Will get me this type of electrical jitter. Just to drag and drop to draw the system, draw this design. Okay, finally, you, here for layout properties, you have to set the sweep iterations. Here I have given um, iteration value is 9. Okay, so just you click in this manner because I will post the OSD file in chat box with these setups. Okay, just you need to analyze what are the simulated parameters, layout parameters are given. Based on that, you just note down. Okay, here uh, click layout, go to parameter sweeps. Here number of sweeps I given here 9. Electrical jitter, you need to define the amplitudes with 0 0.1, 0.1, 0.2, 0.5, 0.1, 0.2, in this manner. Okay. Similarly, the frequency also you give in the form of megahertz, 300, 3500, and 1000 hertz. Based on that, you just give the parameter sweeps value. And then this parameter, the bitrate is 100 MB per second, and time window and sample rates based according to the bitrate will automatically it select with the normal mode. Now don't put any sweep mode here. You set the sequence length is 128 and samples for it 64 and number of samples is 8192. Based on that, you give the layout parameters. Okay, remaining things are same. Okay, now run the simulation. Now we are getting a Q factor value, and this is your minimum BER, and this is threshold, and the height of this eye pattern. This is show the eye diagram. Here now we are getting eye diagram. Also oscilloscope. Here jitter amplitude is 0.5 Vi. In this manner, you just analyze which value is better situation. Based on that, you drag and drop. You mark the point A and B here. This is what A and B. This region you select. By using the marker, you note on A point and B point. Based on that, you just calculate the values as it is from the information window. You will get. Okay. Similarly, for total measurement, by using histogram feature, you just find out. And the next one, basic optical transmitter channel and receiver. This transmitter, just you find the component, you type transmitter. Here, optical transmitter, you choose optical transmitter, just to drag and drop optical transmitter and receiver as it is, and optical attenuation. Here, you set the frequency in terms of terahertz means 193.1. We choose the unit nanometer means you select 1550. Okay, then power you give 0, and bitrate and modulation type is uh, NR type. Your modulation type, you type NR here. Then automatically the transmitter taking the modulation type is NR. Then optical attenuator, you no need to put any values. Then the same thing for optical receiver. Here itself in this optical receiver block, automatically the pin photo detector or APD photo detector you can type. You can choose pin and photo detector. Okay, then low pass filter cutoff frequency, you set 0.75 bit rate, and there is no change between any other tabs. Okay, just you run the simulation, just observe the diagram like this. Okay, we find the maximum Q factor value and BR pattern and all threshold minimum BR value. In this manner, you just observe the output and show and get the bit error rate analysis. What is the high height? What is the threshold value? What is the initiation? And all things you need to measure. That's all. Okay, anyone having doubt means you can ask now.